Hi there, this is Sammy. We'll be going over the SAT chemistry question of the day. Let's get started. The question says the hydrogen ion concentration of a solution prepared by diluting 50 milliliters of 0.10 molarity of HNO3 nitric acid aqueous with water to 500 milliliters of solution is. Okay, so basically, this problem is giving us two volumes and a molarity, and we have to find the other molarity. So it's a dilution problem. We have to use a dilution equation, okay? And we also need to know what happens when you take the HNO3, the nitric acid, okay, and dissolve it in water. And actually, it's a strong acid, so it's going to completely dissociate into its ions. Okay, so one thing we need to do first is we need to label what do we have. Okay, so here we're given volume 1, which is V1. We're given the molarity 1, M1, and we're given the volume 2, which is V2, and we are asked to find molarity 2, M2. Okay, and notice that you're trying to find the hydrogen concentration. They're giving you the HNO concentration. Okay, so when you put the HNO3 nitric acid in water, it's going to dissociate into the hydrogen and the nitrate ion. So hydrogen ion and the nitrate ion. Okay, and as you can see, this is balanced, and 1 mole of HNO3 has 1 mole of H plus. So it's a 1-to-1 ratio. So if they say that you have 0.10 molarity of HNO3, you also have 0.10 molarity of H plus or hydrogen ion concentration. Okay, so we just need to apply the dilution equation, which is M1 times V1 equals M2 times V2. We solve the equation for the M2, and then we plug in the values we have. Okay, and so you can see here we have M2 equals M1 times V1 divided by V2 is equal to, so M1 was a 0.10 molarity, goes right there, times the V1, which is the 50 milliliters, goes right there, divided by the V2, which is the 500 milliliters, goes down there, and you enter all these numbers into your calculator, and you're going to get the 0.01 molarity, and the answer is going to be C.